Hi guys, here's the last video for 10.3. Let's see, we made it all the way to second day, right about here. So we need to talk about infinite geometric sequences. So all the all the series that we've had up until now, we were finding for this one, say 5 terms, right? And then for this one, it was 8 minus 3 is 5, 6 terms for this one. This one, it said the first n terms, and we had to figure out what n was. I think it was 11. Could be wrong. Oh, no, this one was 11. Where it says find the first 11 terms. So there was a set number of terms. Those are called finite series. And so now we're going to switch gears and we're going to talk about what's called infinite series. So an infinite series is one that keeps going on and on, just like you would think. It has an infinite number of terms. It goes on and on forever. And while it may seem that you cannot find the sum of all of those numbers, if those numbers approach 0 as n goes to infinity, if those numbers keep getting smaller and smaller and smaller, we can find the sum of it using this formula here. We're going to take that first term of our series, and then it's 1 minus our common ratio on the bottom. So this only works for a geometric series because in order for us to be able to do this, it has to converge to 0. So why can't we do that for arithmetic sequences? Well, the graph of an arithmetic sequence is a line. So either we are going up to positive infinity or we're going down to negative infinity. But in either way, we're increasing or decreasing without bound, and they're not converging to 0. But for geometric series, what we're talking about here, when we graph those guys, it's an exponential equation. So here's an increasing exponential equation. This is when my common ratio is bigger than 1. And unfortunately for this one, it is also getting bigger as it goes to infinity. So this one does not converge. However, if I have an exponential geometric series that's decreasing, so my r is less than 1, so some kind of fraction, then that means my exponential graph is going to be decreasing, and this guy is getting close to what? It's getting closer and closer to our asymptote, which is at 0. So we say this guy is converging to 0. So only in this case, never for arithmetic series, never for a geometric series where your common ratio is bigger than 1, only for the geometric series where your common ratio is less than 1. All right, so if possible, find the sum of the infinite geometric series, 24 plus 18 plus 13.5 plus ... So the first thing we have to do to see if it's possible is find our common ratio. So our common ratio, remember, is your second term divided by your first term. This guy would reduce down to, let's see, 6 goes in here 3 times, and then to 24 4 times, and this guy is equal to 0.75. Since my ratio is less than 1, we can find this sum. We write the sum as just s. Notice I'm not putting a number down here because it's not a partial sum of the first 5 terms or 6 terms or 11 terms. It's the sum of all of the terms. We have the formula where it's the first term, 24, divided by 1 minus my common ratio, which is 0.75, 0.34. When we work that out, that is equal to 96. All right, let's look at the next example. All right, if possible, find the sum of this infinite geometric series, 0.33, 0.66, plus 1.32. So first find your ratio. For this one, it's 0.66 divided by 0.33. That is equal to 2. Since my ratio is bigger than 1, this is not possible. The reason why it's not possible is because our series is unbounded. And we'll use words like series is unbounded when we get to calculus. For now, you can just say not possible. All right, here we have it in sigma notation. Notice the difference here is instead of going up to some number, we're going up to infinity. So this is my clue that this is an infinite series. And so I want to check my common ratio. Remember, your common ratio was here. Since my ratio is 0.65, that's less than 1. This series is converging to 0, so we can find the sum of it. So the sum is going to be my first term. Oh, wait, do we know our first term? Be careful. This guy here is a sub 1. Is that the first term of this series? No, the first term of this series is a sub 2. So we want to say 3 times 0.65, 2 minus 1. That would be 3 times 0.65, which is 1.95, if my memory serves correctly. All right, so that's my first term divided by 1 minus my ratio, which is 0.65. And so this guy, I have 39/7. Let me put that into a calculator to see what it is in decimal form, since we're doing it in decimals here. So 1.95 divided by 1 minus 0.65 would be 5, and this is a decimal approximation. It keeps going on and on. So I'm going to do it to 5 decimal places, or 3 decimal places, 5.571. And that would be the sum of this series. All right, let's look at another example. This one does start at 1, so the first term for this one is actually 12, which is good. Can we find the sum of it? Well, my ratio is 0.6, that's less than 1, so we can. So it's going to be the sum of first term, because we're at 1 here, is actually 12, over 1 minus my r, which is 0.6. When I plug that into my calculator, I get 30. All right, and that is it for 10.3 for geometric series. Coming up next is 10.5 binomial theorem.